All right, let's chit chat a little bit. We are beginning our last unit. Note how it starts today. Today we have a section, tomorrow we have a section. Wednesday, we are going to do a lab. We're gonna like plug these things into our calculators and do like an experiment. Okay, we're gonna do a lab, like science. And on Wednesday, your homework is going to be a Google quiz. And it'll be like a quiz, not like a 100-point quiz, but it will count in the grade book as in the quiz category. Okay. Thursday, we'll wrap up our new material for motion. Okay. Friday, we'll do some AP work. We'll start our review. Seniors, you have a 4-day weekend. We don't have school Monday. The ACT's on Tuesday. So Wednesday, we will clean up our review and take our test on Thursday. This will be our last chapter test. On next Friday, we will begin reviewing for our final. Our final will be a full-length AP test, so it'll take us 4 class periods to take it. You can retake 2 of the 4 parts, and the final will count as both a final and a test. Now, it is AP style, which means I'm going to grade like the AP style. Okay, so it will be scaled. If you get a 5, you get some version of an A. If you get a 4, you get some version of a B. Yes.
We say like retake it. Time for that, or are we coming in separately?
Class time. So I have 4 days set aside for the final. 1 day after it set aside for going over the final, and then 2 days set aside for 2 days of makeups.
Okay.
So I have 4, 5, 6, 7 days set aside for this whole thing. Okay. By the time we get there, you're going to feel ready. Okay. It's not going to be scary. Okay. We don't have many days left, do we, seniors? Like what?
20.
Okay, so your intro sheet kind of gave you a little bit of information about what we're going to start talking about. All right, so have the pink sheet out, have your notes out. Okay, we are going to talk about linear motion. Okay, and what's important here is that S of t represents position over t time, which is something that we went over in this pink worksheet. You're laughing. Oh, okay. I was like, oh, what's funny about this? Okay. Yes. Okay. Okay, so initially means what is 0? Initially means what is 0? T, thank you. At the origin means S is 0, our position. Okay, that's from your pink worksheet there. All right. So when it says at the origin, that's pretty much just like where we started from. Okay, our point of origin. Okay. Now we're just going to be moving back and forth. So we're going to talk about motion being right or left in terms of position. Are we to the right of the origin? Are we to the left of the origin? Are we moving right? Are we moving left? Okay, so we're just talking about a particle, an object, a being of some sort walking back and forth along a line. Okay, and that's what we're talking about. Instantaneous velocity. Interesting. It's like this word instantaneous has been brought up in class before. How do we calculate velocity? Okay, velocity is distance over time. Oh, so we're talking about a rate of change, an instantaneous rate of change. All right. So for our instantaneous rate of change, the derivative of our position is our velocity. Now velocity, why do we not call it speed? Because velocity has direction. Velocity can be positive, velocity can be negative. All right, so if I do ask you for speed, you would have to take the absolute value of velocity. Okay. So let's talk about, since velocity can have direction, positive and negative, let's talk about the meaning of positive velocity versus negative velocity. If we're talking about moving left versus moving right, positive velocity is going to refer to which one of the two? Okay. Because we have positive velocity, we're moving in the positive direction, we're moving to the right. However, if we have negative velocity, we're moving in the negative direction, we're going to be moving left. So this is something that I am going to ask of you, either analytically, like I give you an equation, or graphically, I give you a graph. When are we moving right? When are we moving left? Okay, this is something that I'm going to ask you to analyze. Okay. So we're going to do this with all sorts of different graphs. So let's go ahead and just talk about this graph right here. Okay, this is my position time graph. And I'm going to be honest, it's not very often that we're going to be given a position time graph, but we are right now. Okay, so what does it mean down here when my position is negative? If our position is negative, what does that mean? We are to the left of, okay, so we are left of origin from 0 to 6, and we are to the right of the origin from 6 to, I'm just going to say 6 to 8. We don't know how long that goes. Okay, so what's happening at time equals 6? At time equals 6, our position is 0, which means we're back at the origin. Okay. Okay. Now, we can determine when our particle is moving to the right versus moving to the left by looking at velocity. And if velocity is the derivative of position, what characteristic about our graph would we look at? Yes, increasing or decreasing. So we're looking at our slope. So look here, we have negative slope until 4, and then we have positive slope after 4. Okay, so since our slope is negative, since our particle is since our position is decreasing from 0 to 4, then we can say that we are moving left from 0 to 4. And since our particle's position is increasing, since our particle's position has positive slope, we are moving right from 4 to 8. Okay. Well, now let's look at what the velocity graph would actually look like. Okay. Let's look at the actual velocity graph. So here's our velocity graph, and we're going to talk about the same sorts of things. Our velocity graph is just the derivative graph. Okay. What do you notice about our velocity graph from 0 to 4? It's negative. Our velocity is negative from 0 to 4, which means our particle is moving left from 0 to 4. Okay, we already talked about this, but I want to talk about what it looks like on this graph. Bless you, bless you, bless you. Notice how our velocity is positive from 4 to 8. So our particle is moving right from 4 to 8. Okay. So if I ask you, is the particle moving right or is it moving left? If we're looking at a velocity graph, we need to just look at, is velocity positive or is velocity negative? However, if we're looking at a position graph, we need to look at, is the position decreasing? Is the position increasing? Moving right. Okay. Do you understand why I had you interpret that graph at the bottom of your pink sheet? Okay. We're going to have to like remember how to read derivative graphs. Okay. You okay?
Yeah.
You always say sure, and I'm never quite sure if you actually mean it.
Oh, I'm sure.
Ugh. Ugh. Okay, when is the particle stopped? Or at rest? T equals what? 0 and 4. Whenever we are at the t-axis here for our velocity graph, our particle is stopped. All right. Physics people, is this like almost making you a little irritated that we're talking about these relationships right now and you didn't know them when you talked about motion? What comes after velocity? Acceleration. Acceleration is the rate of change of velocity, AKA the rate of change of the rate of change, which means what? So our acceleration is the derivative of velocity, which is the second derivative of position. What it is. I honestly can't answer that. I'm wondering if it has to do with the language translation. Yes, the third derivative is called a term. It really is. Okay, now what does acceleration tell us? Okay, it's the rate of change of velocity. Okay, now I am also going to ask you, let's come back up to here. So here's my velocity graph. When do we have positive acceleration and when do we have negative acceleration? So if acceleration is the derivative of velocity, when I'm asking you for positive acceleration, what am I looking for on this graph? Increasing. Okay, that's happening from 2 to 8. And our velocity is decreasing from 0 to 2, so our acceleration would be negative. But that doesn't actually tell us if our particle is speeding up or slowing down. It is not just about acceleration. Okay. We have lots of students in the house today. When we talk about speeding up and slowing down, we have to compare both the direction and the acceleration. Okay, so are the velocity and acceleration going in the same direction or are they going in opposite directions? Okay, so if my velocity and acceleration have the same sign, that means we're going in the same direction, then our particle is speeding up. Okay, if our velocity and acceleration have opposite signs, so they're going in opposite directions, then our particle is slowing down. Does that make sense? Okay. If our velocity is negative, but our acceleration is positive, that means we are slowing down. If our velocity is positive and our acceleration is negative, is that what I just said? Then we're slowing down. But if velocity is positive and acceleration is positive, then we're already moving right and we're trying to go more right. We're speeding up. Okay. Are we okay with that? Do I need to put an example into context? No? Okay. You guys are looking at me like I'm crazy. So let's come up here again. Okay. Let's talk about when we are speeding up versus slowing down. Okay. So our velocity is negative from 0 to 4 and positive from 4 to 8. Our acceleration is positive from 2 to 8 and negative from 0 to 2. So from 0 to 2, what is true about our velocity? Negative velocity, negative acceleration, right? Okay, well, that means that we are going to be speeding up from 0 to 2. Okay, well, after 2, our acceleration is always positive. All right, well, from 2 to 4, we're still moving to the left. We still have negative velocity. Okay, so we're going to be slowing down from 2 to 4 because our velocity is negative, but our acceleration is positive. But then as soon as we hit 4, our velocity is positive, our acceleration is positive. So we're again moving, or we're speeding up. maybe that was a lot to take in. So maybe you need to make a number line and say, okay, our velocity between 0 and 4 is negative, and then after 4 is positive. Our acceleration from 0 to 2 is negative, and then it turns to positive. Okay, and we can see where there's overlap of same, but then here they're different. Okay. Oh, thank you, sir. What questions do you have about this before we look at the acceleration graph? Okay. So here's our acceleration graph. Okay, and we can see that our acceleration is negative from 0 to 2, and then positive from 2 to 8, and that's what we've been talking about this whole time. Okay, but what I want you to do is I want you to look at the position and the acceleration graph together. What characteristic about the position graph is going to give us information about the acceleration? Yes, since the acceleration is the second derivative, if we are concave up, we know that our acceleration is positive, okay? Concave down would mean acceleration is negative. So look how that matches up. We are concave down until t is 2, and then we switch to concave up. Notice how acceleration is negative until 2 and then positive. Okay, so there's a lot that we're going to be able to tell from a position graph. There's a lot that we're going to be able to tell from a velocity graph about what is happening with our particle. And I'm going to back up and I'm going to say, actually, there's a lot of times you're going to see a position graph. There's more times you're going to see a velocity graph. Very few times are you going to see an acceleration graph. An acceleration graph can only tell us about acceleration. A velocity graph can tell us about velocity, acceleration, speeding up, slowing down, and then position can help us with everything. Okay. Now, half of your assignment is going to be reading graphs, but the other half of your assignment is going to be analyzing an equation. Okay, so let's talk about the algebra that we would need to use to do this. So when I'm asking you to analyze the particle's motion, we're going to answer these questions. When are we moving right? When are we moving left? When are we at rest? When is the acceleration positive? When is the acceleration negative? When is our particle speeding up? When is it slowing down? So what should we do? If you were thinking, let's take the derivative, that would be accurate. Okay, so the velocity is the derivative of the position. Okay, Nathan, what's our derivative?
Our derivative would be 6t squared minus 42t plus 60.
Okay, there's our derivative. Now, we're not going to graph it, but we need to analyze where this is positive versus negative. So what should we do with our derivative to help us figure that out? Yes, let's find the zeros. Okay, so I'm going to go ahead and divide both sides by 6. When I set it equal, I'll factor out a 6. How's that? So we have t squared minus 7t plus 10. You agree? Okay, so t minus 5 and t minus 2. Okay. So on my velocity number line, we have zeros at 2 and 5. Okay, and we're always going to have to start when t is 0. Okay, time's never going to be negative. Okay, so if I plug in a number between 0 and 2 into my velocity, do we have positive or negative velocity? Positive. I mean, technically we can plug in 0. 0 is not a critical point. Okay, how about between 2 and 5? If we plug in like 3, we're going to get negative velocity. And then after 5, if we were to plug in 6 for t, we would have positive velocity. Okay, so this is what we can say. Our particle is moving right from 0 to 2 and 5 to infinity. Our particle is moving left from 2 to 5, and our particle is at rest when t equals 2 and t equals 5. All right, so now let's look at our acceleration so we can figure out when we are speeding up versus slowing down. So our acceleration, A of t equals, Cole, what's our acceleration equation? (12t minus 42). So when we set that equal to 0, what do we get? 42/12. 7/2, right? Yeah, yeah. Now, if you kept it as 42/12, I mean, it's fine, but we probably need to know where to put it on our number line, right? And 7/2 is like 3.5. Okay. All right, to the left of 7/2, what kind of acceleration do we have? Positive or negative? Looks like we would have negative. And then after 7/2, if we were to plug in a number into our acceleration, we would have positive acceleration. Okay, so to be honest, I really don't care where we have positive acceleration, where we have negative acceleration, but it's helping us figure out where our particle is speeding up versus slowing down. Okay. Our particle is speeding up wherever our acceleration and our velocity have the same direction. Is that happening from 0 to 2? No, but starting at 2, we have negative velocity, which matches our negative acceleration. And then where would we start to mismatch again? 7/2, okay? But then at 5, our velocity turns back to positive. So after 5, velocity and acceleration have the same sign. Okay. Our particle would be then slowing down from 0 to 2 and from 7/2 to 5. What do you think? Have we learned anything that is like crazy out of control new? Okay. We know how to take derivatives and we know how to analyze derivative graphs. Okay. We know how to analyze derivatives without their graphs. So all I'm asking you to do is just put together that position has a derivative of velocity and velocity has a derivative of acceleration, and use everything we already know about derivatives to help us answer some questions. Okay. So I'm going to help you get started on your assignment.